Okay, how y'all doing? For this video on Paleo News here, we're going to go over another couple of papers here. And they're not related, except for a look at taphonomy. Well, one's about taphonomy of feathers, and the other one's about cervical ribs of woolly rhinos. And we'll explain why that is. Let's first of all talk about the taphonomy of feathers. This one is experimental taphonomy of keratin, a structural analysis of early taphonomic changes. Okay, for those who don't know, taphonomy is a study of how things, die and decay. Very important research, especially in paleontology. Now, this one's from Evan T. Seta, Christopher S. Rogers, Richard A. Brooker, and Jacob Vinther. This is published in Paleos, 2017. And of course, I'll link them down below. I'll read the abstract. The evolution of integumentary structures, particularly in relationship to feathers and dinosaurs, has become an area of intense research. Our understanding of the molecular evolution of keratin protein is greatly restricted by the fact that such information is lost during diagenesis and cannot be derived from fossils. Diagenesis is when sediments, we got sediments that turn each other to rock, sedimentary rock. We got loose soils and then compressed into harder substance. In this study, decay and maturation experiments are used to determine if different keratin types or integumentary structures show different patterns of degradation earlier in the taphonomic histories, and if such simulations might advance our understanding of different fossilization pathways. Although different distortion patterns were observed in different filamentous structures during moderate maturation, and ultrastructural textures unique to certain types of scales persisted in moderate maturation, neither of these have been observed in fossils. It remains uncertain whether this degradation pattern would even occur in natural sediment matrix, where microbial and chemical decay happens well before significant diagenesis. It takes some time for remains to be buried, meaning that keratin may not be left for moderate maturation to produce such patterns. Higher, more realistic maturation conditions produce a thick and water-soluble fluid that lacks all morphological and ultrastructural details of the original keratin, suggesting that such textural or distortion patterns are likely to be observed in fossils. Although different degradation patterns among keratinous structures are intriguing, it is unlikely that such information could be recorded in fossil record. Calcium phosphates and pigments are a surviving component of integumentary structures. Thus, the results are likely of more relation to the archaeological record than fossil record. Other noteworthy results of these experiments are that melanin may not be the leading factor in determining the rate of microbial decay in feathers and may reduce the rate of degradation from maturation, that the existence of Rhachis filamentous subunits similar to Pulmulaceous barbules is supported, and the previous reported dinosaur erythrocytes may be taphonomic artifacts that degrade organic material. Okay. To sum this up, okay, I'm summing up a lot of things, but basically they are trying to study the decay of keratin, which is the stuff that makes your fingernails, rhino horns. The more keratin you have in your tissues, the harder it gets. And of course, keratin is in feathers. So what they did is they took a series of feathers from various parts of birds, mostly turkey. They studied different keratins because you got alpha keratin, beta keratin, and even I think that's your theta keratin, and these are different keratin molecules. So they took different samples of feathers and even some scales from both crocodiles, and birds. And he wanted to see by putting them in solutions involving various forms of some yeast and some different forms of chemicals. Let's see. Salt broth is what it is. So sodium, ammonium chloride, sodium chloride, potassium, hydrophosphate, and various other things. They put these different types of tissues into these broths, some with yeast, and he wanted to see how it decayed. And as the abstract told, okay, we see different results, but we don't see this in the fossil record. But such studies like this could be from it could be useful in archaeology. You know, long story short. Now this is a 12-page paper, but it's a little bit packed, and a lot of one of the problems I have is that it doesn't when they tell which samples and what, but it probably would help if they had a visual diagram of you know, and led to the results. But it shows some photographs of what the keratin looked like after it was broken down and everything. And I think, okay, well, this one, you know, in attempting to find a way to see if, as keratin like this dissolves, they could probably, you know, see if it, you know, again, see if you can find it in like preserved feathers. It's a start. That's what this is a start. This study right here doesn't determine everything in the long run. As I say, it doesn't really doesn't seem that useful for paleontology. I say not yet. More experience, because you got to take in a lot more factors. You got to take not only the chemicals involved, different microbes can break it down in certain ways. You got to think about the temperature, the sediments that would be buried in, you know, what have you. A whole lot of factors. So this is a good start. And it seems to be taking a jab at Mary Schweitzer, who is famous for finding the soft tissues in the T-Rex and couple other dinosaur bones. I won't get into that. But that's that one. So you might find it interesting, especially if you're into feathered dinosaurs, and you're interested in feather structures and how it might... how this might, you know, it's a good start that can get into further in studies. So not much to say about this one. Now the other one here, excuse me, a bit more interesting. Despite the fact that it's a little longer paper, it's actually a quicker read. This one is high incidence of cervical ribs indicates vulnerable conditions in late Pleistocene woolly rhinoceros. Rhinoceroses. Would it be rhinoceri? Maybe I'm wrong. This is Alexander A.E. Van de Geer and Frietzen Galis. It says, it looks like it's published in Pure J. Let's see. Yeah, Pure J is the journal that was published in 2017. And abstract. Mammals, as a rule, have 7 cervical vertebrae, a number that remains remarkably constant. Changes in this number are associated with major congenital abnormalities, pleiotropic effects, that are, at least in humans, strongly selected against. Recently, it was found that late Pleistocene mammals, Mammuthus primogenus, from the North Sea have an unusually high incidence of abnormal cervical vertical ribs, approximately 10 times higher than that of extant elephants. Abnormal numbers were due to the presence of large cervical ribs in the 7th vertebrae, indicating the homeotic change from a cervical ribless vertebrae into a thoracic rib-bearing vertebrae. The high incidence of cervical ribs indicate a vulnerable condition that is thought to be due to inbreeding and adverse conditions that may have impacted early pregnancies in declining populations. In this study, we investigate the incidence of cervical ribs in another extinct late Pleistocene megaherbivore from the North Sea in the Netherlands, the woolly rhinoceros, Coelodonta antiquitatis. We showed that the incidence of abnormal cervical incidence of abnormal cervical vertebral numbers in the woolly mammoths is unusually high for mammals. 15, to 6. It looks like 6%. in 32 samples, and much higher than the extant Rhinoceros 0%. This indicates that the woolly rhinoceros live in vulnerable conditions, just like woolly mammoths. The vulnerable condition may have contributed to their eventual extinction. Okay. Now, in this study, you can find the pictures of what they're talking about. Okay, if you know basic mammal structures, we have 7 neck vertebrae in our ribs before it gets to the thoracic. Now, there are 2 groups that are exceptions, the sloths and manatees. But usually we find more than that. There's indicating of a problem. What is that? Well, the 7th neck vertebrae has an extra rib that kind of goes into the thoracic, and this is a sign. I mean, it's not necessarily a problem in of itself, but it's a sign that there are other morphological problems, like say in the Hox genes or some other genetic problems that you can find in other parts of the animal. So, as I say, it's not necessarily a problem in itself, but it's a sign that there's a problem. And they found this in woolly mammoths, and in this study shows that there's a woolly rhinoceros as well. So, and this study shows some good positive correlations that they were having the same problem with the woolly mammoths, and it may suggest that as the environment was changing, their populations were decreasing, and whatever was there was also a high probability of more inbreeding, leading to this problem. So I find this a very interesting study. It shows the vertebrae, the profiles, and what the parts of it are in the healthy ones, and what some of them look like in the unhealthy ones. Some of the other things that they found in these problematic rhinoceri that was having that 7th vertical problem is that they were given fused vertebrae. They were, and here and there, some of them almost merged into one single bone. So, and say the conclusion here is, in conclusion, the high incidence of large size of the cervical ribs in the late Pleistocene woolly rhinoceri of the North Sea indicates a strong vulnerability given the association of cervical ribs with diseases and congenital abnormalities in mammals in general. So, if so, that vulnerable condition of woolly rhinoceros in mammoths may well have contributed to their eventual extinction. So, it doesn't seem like much, but if you're into mammals, this could be, and it's one of the great mysteries about why did these large megafauna from the Pleistocene died, and this could be a tiny clue that could lead into that. So, while not the greatest papers you would expect for those who have watched this series so far, sometimes you have to, when it comes to doing research, you have to go through what may look like boring stuff. And it's good to keep in mind, because when something else comes up, you can like, hey, wait a minute, what about this right here? You can always ask questions. I'll link them down below as normal. Thank you all for watching. You have a nice day.